Okay, so I'm picking up from the previous video where we're talking about mixtures, and I wanted to reiterate where we got this from. So we're figuring out how many milliliters of a 12% acid solution should be mixed with 500 milliliters of a 20% acid solution mixture to obtain a 17% acid solution. So what's going on is we've got the three percentages. The 17% is the one that's in the middle when you put them in order from smallest to largest. So the 17% is the one that's off all by itself on one side of the equal sign, because that is the result of mixing the other two together. It doesn't work any other way. And we are looking at the total volume is going to be the unknown volume from the 12% solution plus the 500 milliliters from the 20% solution. The total volume is whatever X is plus the 500. And the partial volume, the amount of pure acid, is going to be 12% of X. So this is another way of writing 12% of X. This is another way of writing 20% of 500, and this is 17% of X plus 500. But each of these decimals can be rewritten as a fraction. So when we say that the partial volume from the 12% solution, meaning the pure acid that went into the 12% solution, plus the pure acid from the 20% solution, adds up to the amount of pure acid that's in the mixture. So this is one way of writing the equation, and it's perfectly acceptable to use that way. But because of the fractions, and then you can multiply both sides of the equation by 100, what we can do is to rewrite the equation like this. So because it's an equation, we don't need those decimal points. We can just use the 12x plus 20 times 500 equals 17 times x plus 500. So what I'm going to do is I'm running out of room here, so I'm doing it on a separate piece of paper, and I have just copied that equation. So now I'm just going to demonstrate the algebra. So 12x plus 20 times 500 is 10,000 equals, and now we're going to distribute that 17, so it's 17x plus 8,500. And now we're going to go ahead and solve the equation. We're going to gather our x's on one side, and that's the way I prefer to do it, is to look at the x's first. I'm going to subtract 12x from both sides. If I had subtracted 17x from both sides, that would have made things a little bit trickier, because then I would have ended up with a negative x term, and this way I keep it as a positive x term this way. So now I've got 10,000 equals 5x, excuse me, I'm spelling 5x crazy here, 5x plus 8,500. And now I decided to keep my x's on this side, so I'll subtract 8,500 from both sides. These guys add up to 0, and now I've got 1,500 equals 5x, and divide everybody by 5, and that gives me 300 equals x. And since we're doing so much algebra, it's like, well, wait a minute, what does that mean, 300 equals x? So going back to the problem, x we designated was up here. X is the number of milliliters of the 12% solution, which answers the question, how many milliliters of the 12% acid solution? So the answer is 300 milliliters of the 12% acid solution. So now that we are aware of that shortcut way of setting up the equation, let's go ahead and do that again with this one. So the first part is a really important part, is to set it up correctly. So we've got 400 milliliters of an 11% solution. How many milliliters of a 19% solution should be mixed with it to obtain a 14% solution? So let's look at those percentages. We've got 11, 19, and 14. The one in the middle is the 14%, so that one can go here. The other one, you can put 11% here and 19% here, and mathematically, because addition goes both ways, you can put 19% here and 11% here. It doesn't matter which way you do it. I'm going to be less confused if I do it in the order that it appears in the problem. So I'm going to say the 11% goes first and then the 19%. So what's going on is there's 400 milliliters of the 11%, so 400 milliliters goes here. And we're saying how many milliliters of the 19% solution. So X goes here because that's going to answer the question. So now what's the total volume of the 14% solution? Well, when we add the volume of the 11% and the volume of the 19%, that's going to give us this way. So I'm going to write it the same way it appears. 400 plus X. It is perfectly acceptable to write it as X plus 400, and that's of course in milliliters. So what we're saying is here, this is the percent concentration or strength. This is the total volume. Now we're ready to talk about the partial volume. And what I'm going to do here is I'm going to take that shortcut that we learned from last time and say, okay, the equation is 11 times 400 plus 19 times X equals 14 times 400 plus X. So you see how quick it is to get right from this step to the equation step. And what's going on is it's the percent without the percent sign. You don't need it as long as you're consistent and do it for every part of the equation. 11 times 400 plus 19 times X equals 14 times 400 plus X. And now we can just jump to the algebra. 11 times 400 can be simplified. That's 4,400 plus 19X equals 14 times 400 plus 14 times X. So simplifying again, 4,400 plus 19X equals 14 times 400. My brain isn't working so good, so I'm going to use the calculator for that. 5,600 plus 14X. And I'm going to let the X's drive to make sure that I don't end up with a negative number, so I'll subtract 14X from both sides. By the way, if you do end up with a negative answer for one of these problems, it's probably not just a situation where you need to change the sign of your answer. What probably happened was your mixture percentage was not between the other two. So if you try to make it 11%, 14% adding up to 19%, you'll end up with a negative number. So be careful there. Okay, so that's going to be 4,400 plus 5X equals 5,600. And then we'll subtract 4,400 from both sides. And that gives us 5X equals 1,200. Divide everybody by 5. I'm running out of room again. Put it up here. So that's going to be X equals 240. And over here we see what X was. It's the number of milliliters of the 19% solution. So our solution is, our answer is 240 milliliters of the 19% solution. And does that answer our question? Yes. So there's our answer, is 240 milliliters of the 19% solution. Okay, let's look at another one. How many milliliters of water, which is a neutral solution, should be mixed with 500 milliliters of D10W to obtain D5W? So there's some words here that you might not recognize. We did talk about a neutral solution in my previous video, but let's remember that neutral solution means that it has none of the main ingredient in it. And you might not recognize D10W, but that means dextrose 10% in water, and D5W means 5%. And now that we've got our percentages, it should be obvious that the 5% is in between the other two. So 5% goes here. And the other two, so the water is mentioned first, so I'll make that first. We'll, remember that this is the water. And then the other one must be the 10%. And that's the D10W. And this is the D5W. So that's what's going on here. So, okay, now let's look at the volumes. How many milliliters of water? So what's going to answer the question is the number of milliliters of water. So we'll make that X milliliters here. Should be mixed with 500 milliliters of D10W. So that's going to be 500 milliliters here. To obtain D5W, well, we're not told how much volume this is in the mixture, but we can write that up as X plus 500, right? Because we know that this volume plus that volume must equal the total volume of the resulting D5W. So our equation is the same way we've been doing it, that the percent times the volume. So it's 0 times x plus 10 times 500, right? Percent times the volume equals the percent times the volume here, x plus 500. Did you notice that every time I use the x plus 500, I put it in parentheses to remind myself that when we are multiplying by the percentage that we have to distribute it. You don't just multiply it by the x and then add the other volume. It's 5% of the total volume, not just the first term there. Okay, so here's a really tricky math thing to remember. Algebra, what's 0 times x? I'll give you a hint. It's not x, it's 0. 10 times 500 is a little easier. That's 5,000. Equals, and now we got to distribute the 5, so it's 5x plus 2,500, because 5 times x plus 5 times 500. Okay, so 0 plus 5,000. Even though there was an x here, that x kind of canceled out, because anything times 0 is 0. So 0 plus 5,000 is just 5,000. Whoops, bouncing around the camera a little bit. Sorry about that. Okay, so now we need to solve for x. So we're going to start by, well, there's only x's on one side, so we only have to deal with the numbers. We're going to subtract 2,500 from both sides. So these guys add up to 0, so we got 2,500 equals 5x. And now we'll divide everybody by 5. That gives us 500 equals x. And remember what x was. X was the amount of water. So that is 500 milliliters of water. I'm going to get fancy here and use the chemical formula for water, H2O. Now you might be saying, hey, I kind of thought that's what it would be, because 5% is exactly halfway between 0% and 10%. So it makes sense to me that these are equal amounts. That's fine if you thought of it that way. But you know, this is like a mathy way to do it to make sure that you have it right. So let's look at another one. How many liters of a neutral solution should be mixed with 1.5 liters of a 15% solution to obtain a 12% solution? So there's a lot going on here, but remember that keyword neutral means 0%. So when we're looking at our percentages, we got 0%, 15%, and 12%. So the one that's in the middle, when you put them in order from largest to smallest, or smallest to largest, is the 12%. So 12% definitely goes here. Plus, you can tell by the wording of the solution that the resulting solution is the 12%. Any way you slice and dice it, that's the way it's going to be. So the first thing that's mentioned is the neutral solution, so I'll make that first, the 0%, and then the other one is the 15%. Now this is the first one where it isn't milliliters, but the math still works. So it's 1.5 liters of the 15% solution. That's going to be 1.5 liters here. So how many liters of the neutral solution? We're going to make that x so that it answers the question. And therefore the total volume is the sum of these two volumes. So again, remember, good habit to put that in parentheses. And that's liters. Okay, and now when we set up our equation, we're going to take that shortcut again and make it 0x plus 15 times 1.5 equals 12 times x plus 1.5. So this is very similar to that last problem. We just added a little bit more words around it, but it's the same kind of situation, that these add up to 0. So you don't even have to worry about that. What's 15 times 1.5? That's 22.5. And that's going to be 12x, and then distributing 12 times 1.5 is 18. So again, we're going to solve for x, and x is only on one side, so we're going to start by subtracting 18 from both sides. So now we got 4.5 equals 12x. Divide everybody by 12. So 4.5 divided by 12 is 0.375. So that tells us that our answer is 0.375, and we can look at our units based on our setup. It was x liters, so it's liters. So x is 3.75 liters of the neutral solution. Okay. We are out of time, but I will do more in the next video.